everyone. Welcome to this lecture series on digital electronics. In today's lecture series, we are going to discuss about demultiplexer. So demultiplexer is again a combinational circuit that performs the reverse operation of multiplexer. Do you remember what is a multiplexer? Multiplexer is a device which receives 2 power n outputs and gives only one output. Right? It acts as a data selector. Out of the 2 power n input signals, based on the selection line, it will send only one signal as output. Demultiplexer is a reverse process. So in the transmission, in one end of a communication system, multiplexer is installed, then in the other end, demultiplexer has to be installed. Demultiplexer is a data distributor. Multiplexer is a data selector and demultiplexer is a data distributor which takes a single input and gives several output. Demultiplexer is a combinational circuit that has one input line, 2 power n output line and n selection line. We have n number of applications for demultiplexer. This is a typical example wherein in the system in the drive will be having all the data. So source is single. Using a demultiplexer, either the data can be given to a printer or it could be given to a fax machine or it could be given to another inkjet kind of printer or it could be given to a pen plotter, right? So the outputs can be distributed to any one of these cases, but input is single input. So based on the selection line, any one will be chosen. So this is a demultiplexer. It is used in data routing. It is used in digital control systems. It is used in data transmission and synchronous systems. It is used in data acquisition systems. It is used for generating Boolean functions. It is also used in serial to parallel converters. Very commonly it has been used. Multiplexers is also used for broadcasting of ATM packets. Demultiplexers is also used to design automatic test equipments. So all these things are done by demultiplexers. There are different types of demultiplexers. That is 1:2. That is one input. Input always for a demultiplexer it will be 1 and the output varies. Depending on the selection lines, it could vary. So 2 in outputs can be there. So 1:2, 1:4, 1:8 and 1:16 are the among many different combinations, many different varieties. We have this as common types. 1:2 demultiplexer is a device which has only one input and two output combinations will be there. And here the selection line will be one selection line. So if it is one selection line, then two combinations can be there, 0 and 1. So we have D and 0, we have 0 and D. Similarly, from this we can write the Boolean expression, right? So y1 will be equal to ds dash, y2 will be equal to ds. So for these Boolean expressions, the demultiplexer circuit can be drawn. Similarly, for a 1:4 demultiplexer, so if it is a 1:4 demultiplexer, then we'll be having one input and four different combinations of output with two selection lines, obviously. So this is the truth table of a demultiplexer, right? So four different combinations of the selection lines are there. When 00 has been the selection line, y0 will be chosen. When 01 is the selection line, y1 will be chosen. When 10 is the selection line, y2 will be chosen. 11 is the selection line, y3 will be chosen. And from this, we'll be writing the Boolean expression. For example, if it is y0, then see the different things, the different minterms are, this is 0 here, this is 0 here, it means S1 dash, S0 dash, and then A. Similarly, for y1 is equal to A into S1 dash, and here it is S0. Then after writing all these Boolean expressions, we'll be drawing the circuit. So if you see here, all these are 4 AND gates. Three input AND gates have been used, and here we have S0 dash as well as S1 dash. So from S0 and S1, in order to tap the inverted version of that, we have used NOT gates. Similarly, we have 1:8 demultiplexer, wherein one input will be there and 8 outputs will be there with 3 selection lines. This is the truth table for a 1:8 demultiplexer with Boolean expressions and circuit diagram. The circuit diagram may look complex, but once if you understand and realize this equation, then it's very simple. And this is for your assessment. Thank you.